Hello.
Hello. Can I help you?
If you think about in the banking space, right? Someone goes to apply for a loan or a mortgage or something like that.
I want to buy a house and I need a mortgage.
Great. Are you a new client? Then I'll need some information about you.
There's a variety of information that is collected about them.
So, first of all, name, date of birth, gender.
Sally Armstrong, 2nd of June 1983. Female.
This information could then, be fed into an algorithm that makes a prediction about whether or not they are a desirable candidate. Will they pay this loan back? Yes or no, that kind of thing.
So, that was it. Now let's look and see what the computer says. Oh, I think we have a problem.
And it's possible that you could have a negative response. You ask the individual at the bank, why is this? And the individual could say, I don't know. We don't understand all of the details of the system.
I don't know. We don't understand all the details of the system.
This is not the way we want public systems or private systems to function.
AI and us.
AI and us.
Und wir.
KI und wir.
What artificial intelligence
Means for our lives.
Was künstliche Intelligenz
means for our lives.
Was künstliche Intelligenz für unser Leben bedeutet.
An Alexander von Humboldt Foundation Science
Podcast.
Ein Wissenschaftspodcast
der Alexander von Humboldt-Stiftung.
Episode 4. Do we know what AI is doing?
Most modern AI systems which we currently use are based on neural networks, which are effectively black box models. I mean, we actually know exactly what a neural network does, but it's so large that no human can really interpret it.
Neural networks are impenetrable, says Daniel Rückert. They are given input and deliver output. They recognize a dog or a cat, a stop sign or a speed limit, a tumor or a rare disease. But how they do it is still a mystery. Sometimes this isn't a problem.
For example, in the field of radiology, if we want to automate measurements, we can show the radiologist exactly, for example, how we have computed the volume of the tumor by outlining the tumor on the screen. And the radiologist can decide, yes, this looks correct or it doesn't look correct. But we don't really need to explain why we've made that particular delineation of the tumor.
Says Alexander von Humboldt professor Daniel Rückert. But often, the why is important.
It's clearly a problem if you would like to use the results of your AI models, for example, for generating new hypotheses about how a disease develops or what the origins of a disease are. So many researchers in the biomedical field would, for example, say that a black box AI algorithm is not very useful because they also want to understand the mechanisms behind certain processes which underlie, for example, certain diseases.
You want to know why it works. That's another aspect of science. It's not only the technical part, you want to get the problem solved, you also want to understand why this machine is actually doing what it does. And that's something that we actually lose in the last few years, more and more.
Sometimes it worries him, says Christian Becker-Asano, professor of artificial intelligence, that scientists are perfectly satisfied when something works without understanding what's going on in the background. This leads to AIs that work fine for the most part, but in some situations suddenly don't.
We have great achievements in practical applications with some very mysterious mistakes that the machines seem to make if there's some noise in the image. Which we don't understand why, because we don't know what the algorithm really is doing inside.
Humans can recognize a stop sign even when the image is noisy or the colors are wrong. But AI can get confused even by just a sticker on the stop sign.
It does the job in that moment, very well on the test data and also on the learning data. And then we hope then if we put this into the cars, for example, then we actually hope that under all these conditions that are out there, weather and lighting and everything, that it can still detect reliably the stop sign at the crossroads.
The main problem is that when the artificial intelligence makes an error, it's impossible to trace. We can't identify exactly why the error occurred, and we can't be certain it has been rectified.
When there was a mistake and the car didn't stop and the stop sign seemed to be misclassified as something else, we could, of course, in theory, just take the memory at that moment in time, which is a huge amount of data, inside your computer and make a snapshot. That's the representation of the neural net at that moment. That's the moment in time where the machine made a mistake. Because it cannot explain itself, we can only look at the memory and say, wait, this is just a lot of data.
Even for the people developing the technology, what goes on inside the neural network is too complex to deal with. It's impossible to interpret the data chaos. The usual way of improving AIs is to change the selection of data the AI learns from. But making the right choice of training data is difficult in its own right. Daniel Rückert.
Adding, for example, new training data does not guarantee that, for example, something which was working before is still working, because you don't have a good understanding of how this black box model works.
Making the black box transparent would be an important step in developing AI. But for users to be able to trust AI, something more is required: explainability.
Da geht es gar nicht darum, It's not actually about saying what's going on inside the algorithm, but also knowing the answers to the things people are interested in. For example, when you want to explain to someone how to drive a car, you tell them how the accelerator functions, what the speedometer does, and when you have to change gears. You don't necessarily need to tell them how an injection pump works and what the difference is between a 6-cylinder and a 4-cylinder engine, or a rotary engine, or an electric car, or whatever. No, you don't need to know all that in order to drive well.
Das heißt, wenn ich Autofahren erkläre, dann erkläre ich jede Menge und auch wichtige Dinge, aber ich mache nicht unbedingt das Auto transparent.
Which means when I explain about driving a car, I explain a great deal, including important things, but I don't necessarily make the car transparent.
Tobias Matzner, professor in the Department of Media, Algorithms and Society at Paderborn University. For him, it's important that people understand what happens to their data when they use artificial intelligence, and that we are told what part of our data influences algorithmic decisions.
Imagine you are applying for a job. An algorithm rejects your application. Then you're not really interested in how the algorithm works, but you are interested in what would have to be different about you in order to get the job. So, what features of my application would have to be different for me to be accepted? What was the reason I was rejected?
Und das kann man ein Stück weit sagen.
And to some extent, we have an answer to that.
This is not a theoretical example. A large global corporation really did develop an AI that was supposed to help select applicants. Humboldt professor for the applied ethics of artificial intelligence, Aimée van Wynsberghe.
They were using a recruitment tool, the use of AI to recruit other individuals. They used 10 years of historical data to create that model. When they were actually then going through CVs or resumes to choose candidates for these positions, they found that the model was only recommending male individuals for the higher level positions, never the female individuals.
Another case of artificial intelligence practicing discrimination. Injustices from our own world have found expression in the training data, and the AI has adopted them. A similar case occurred at another major corporation. Their AI offered women worse terms for their credit cards than men. Errors like this are scandalous and hit the headlines. But
instead of using this recruitment tool to actually be a part of the recruitment process, using this recruitment tool to understand the historical biases of the company, that is a fascinating use of the technology. That is how the technology sheds light on certain forms of inequality. And then we have a choice. Do we perpetuate these systems of inequality, or do we stop and make a difference right now? So I do think that AI has the potential, but I say that hesitantly and carefully because it's up to us how we decide to use it.
to some extent, AI can hold a mirror up to us. The problem is simply that not all the errors AI makes are easy to identify. When an algorithm rejects a mortgage request, for example, it is not necessarily clear whether it was a good or a bad decision.
If someone discriminates against someone else because of gender or skin color or whatever, then we can address the issue and say, hey, that's not right. But if someone is discriminated against because of 200 random features, then it's really difficult to address.
Dann ist das extrem schwer überhaupt zu adressieren.
So, black box AI could lead to new forms of discrimination.
This was episode 4 of AI and Us, a science podcast by the Alexander von Humboldt Foundation. The experts in this episode were Christian Becker-Asano, Professor for Artificial Intelligence at the Hochschule der Medien in Stuttgart. Tobias Matzner, Professor in the Department of Media, Algorithms and Society at Paderborn University. Daniel Rückert, Alexander von Humboldt Professor for Artificial Intelligence in Healthcare and Medicine at TUM Munich. And Aimée van Wynsberghe, Alexander von Humboldt Professor for Applied Ethics of Artificial Intelligence at the University of Bonn.
In the next episode, how does AI think?
You can't teach an AI to go to a restaurant and enjoy a nice meal.